Good morning, students. Hello, can someone confirm? Any one of you, please,
Morning,
can you
sir.
confirm if? Okay, thank you very much. Yeah, thanks for confirming. I just need to make sure that I'm audible. Thank you very much. Welcome to lecture number 5. I believe we have new students according to the updated ITS register. So far, we've got 111 students. So, just to assist the newly registered students, I'm going to show you what we've covered on Moodle very briefly. So, our first session was on the 21st of Feb. That's where we went through the course pack, just basic info you need for this course, including study notes, template, etc. You need to ensure that you log into Moodle so that you can be automatically enrolled on MS Teams. The first 4 lectures on MS Teams have links available on Moodle so that you can look at them again if you want to, or if it's the first time, then you're more than welcome to go through each and every lecture. And then if there are any questions, then you're more than welcome to send me an email, and then I will then respond or maybe phone you back via MS Teams. I always keep the class register, as you can see, lecture 1 up to lecture 4. So just make sure that you don't just sign in and then sign out, because it can be picked up on the MS Teams register. So for new students, please, it's important that you go through everything that is on Moodle. Right, so what I want to show you here is a term planner, so that we can confirm a few things, right? So this is the term planner. Just waiting for it to open, sorry. So according to the term planner, we have covered the revision, which consisted of calculating the support reactions. We've completed shear force diagrams. Today we're going to be talking about bending moment diagrams. So it's very important that you keep up to date with the work we've covered so far.
Sorry, sir.
Right. So yes, sir.
As I can see
I'm
on
listening. No, it's fine. You can talk. It's okay.
As I can see on the term planner, the practicals are supposed to start this week. Are they going to start, and when will we do the practicals? Because there is no allocated time on the timetable for structural mechanics practicals.
Okay, right. So this okay, I'm going to answer your question. So as soon as you're allowed to come to campus for lectures, practicals, then obviously I will then inform you the exact session or date you'll need to come to do your practicals. Ideally, they should be done during lecture times. So basically, the way it's shown in timetable, all 4 sessions are dedicated to lectures. The reason I'm actually we're doing it that way is because we don't cover practicals from week 1 up to week 15. So the challenge I'm having is this.
Sorry, sir.
If I show practical.
Sorry, sir. Could you please repeat, because someone just removed me from the meeting while you were just explaining.
Yes, Marcus.
Could you please repeat what you just said? Someone just removed me from the meeting.
I think you're breaking. Can you?
Can you please?
Sorry, I didn't hear what you said.
Can you please repeat what you were saying, as I did not hear what you were saying? Someone removed me from the meeting. Sir?
Okay, my apologies about that. Sorry, Makazi, can you just confirm? Can you hear me clearly now?
Yes, I can hear you. Someone was removing me from the meeting, sir.
Oh, okay. Okay, no. Okay, so sorry about that. Well, what I've done is I was using the Wi-Fi, so I've actually switched off the Wi-Fi, and then I'm using the cord at the moment. So I think also from my side the network will be much more stable. So what I'm saying is this: on the timetable, my timetable. In fact, I wanted to show you that so that we're all on the same page. Okay, this is my timetable. Can you all see it? Any confirmation, please?
Yes, we can see it, sir.
Okay, excellent. Right. So on Monday, 11 to 1, and on Friday, 8 to 10, it shows everything is lectures. The reason for that is this. If you look at the term planner, you will see that we only have, or we need maybe, let's say, between 3 to 5 weeks of that time to actually do lectures, practicals. So I don't want to find myself in a situation where then on the timetable, it says practicals, maybe from 11 to 12. And then when the auditors go to the prac venue, they don't find me there. Okay, because the explanation that, practicals only take 5 weeks, but then it's allocated 15 weeks. It's a little bit of a tricky one to actually, put forward all the time. So to make my life easy and everyone's life easy, this is how we do things. If I need you for lectures, we're on lectures. If I need you for practicals, we need on practicals. If we need to do tutorials, we're on tutorials at any time that's shown within the allocated time for this module. So this module is given Monday 11 to 1, Friday 8 to 10. That's the time that is dedicated for this module. I will tell you when to come for practicals. I will do tutorials with you at any time I feel it's necessary to do it. I don't know if that answers your question.
Yes, sir. Thank you, sir.
Okay, excellent. Right, so I just need to, I almost forgot one thing here. Test 1 is still on the 18th of March. Okay, and test 1 will cover a revision, which is support reactions, shear force diagrams, bending moment diagrams. Okay, those 3 things will be covered in test 1. Right, so I need to switch off this one now. Now what we need to do is this, is to go through today's work. So today, maybe I might as well just switch off this and let's switch it off completely. Lecture 5. Are we all, before we proceed, are we all clear about the Sun Convention for shear? Okay. If there are any questions, please ask. Okay. Right, thanks. I'm assuming that we're all clear about the Sun Convention for shear, but I think I've explained it more than enough. And then let's move on to the second one, the Sun Convention for bending, because this is what we're going to need today, right? To know, right? So in terms of a bending, this is the way we're gonna do it. So I will switch off my video. It's just that I wanted to show you this before we proceed. So if you have a beam, okay, this is a beam, and the beam or the load on the beam is causing the beam to bend like this, causing the beam to sag. We call this positive bending. If the load is causing the beam to hog, this is negative bending. So this is positive bending, sagging. This is negative bending, hogging. So let's say you're given a cantilever. So this is a cantilever, and you apply a load here. You can see that the beam is hogging. This is a cantilever at home, and the wind is blowing this side, so it's pushing the cantilever up. You can see that the cantilever is now sagging. Right, so in terms of the sign convention, if the load is causing the beam to sag, that's going to be positive. If the load is causing the beam to hog, we'll give that negative. So I'm going to have to use an example to then show you how we're going to apply this information. So what we need to do is this. Let's go to the study notes on page 39. The gentleman said last time. So page 39. So this is the first one we're going to do, the very first one, question 1. So remember, we've done part 1, calculating the support reactions. We've done part 2, drawing shear force diagrams. Today, we're doing bending moment diagram, right? Which is the fourth one, but we'll come back to the bending moment equation. So the question is, how are we going to draw the bending moment diagram for this beam? We're going to go to any point along the beam. We'll take any point along the beam. If we choose to go to node B, we will then have to decide whether we're going to take some of the moments on the left-hand side, or we'll take some of the moments on the right-hand side to calculate the moment at that particular point. So I can go to node C, and I can consider the right-hand side, which is easy because there's only VD. Or I can go to node C and take some of the moments considering the left-hand side, which you will get the answer, but obviously there's quite a bit of forces to deal with. You have VA, you have 10 kilonewton per meter, as well as 30. At C, the lever arm for 50 is 0, so 50 doesn't come into play. So now I need to use this document camera. So we're going to do some numbers. I'm going to ask you to grab your calculator as well. so that we can all work together. So this is tutorial 8. And this is tutorial 8, question 1. We're going to draw the bending moment diagram. The units is kilonewton meter. Okay, that's what we're going to do. So I just need to get something to hold this in place. Otherwise, it's going to cause problems. I'm going to ask you a question. It's not a tricky question when I finish doing this. Looking at this beam, what is the bending moment at node, let's say node D? What is the bending moment at this point? Can anyone answer that question if possible? What is the bending moment at node D?
0, sir.
Okay, the bending moment at node D is 0. Thank you very much. But I'm going to show you why it's 0. So let's take MD, take some of the moments at node D, and then we're going to look at the left-hand side of node D. Okay. My apologies about that. It wasn't me. Right. So let's continue. So I'm going to go to node D, and then at node D. Okay, my apologies, students. This lecture is being recorded, and I think we will continue. So Okay, what I'm gonna do, students, I have pre-recorded lectures for this session. It was done a long time ago. So if the destruction of MS Team lectures continue, then I will obviously upload those lectures on Moodle, and then each student will then have to contact me via MS Teams to discuss any problems that you may have. Okay, so am I still audible? Can anyone confirm that? Okay, right, let's look at question 1.
Say, we don't have residences, we don't have money, so we won't study. So say, we call upon you to end this class immediately. We won't study.